Hey there, my name is Jake, and today we're going to talk a bit about trigonometry. More specifically, about the cosine and the sine of alpha plus beta. I want to tackle them because they're a bit complicated, especially if you take a more mnemonical approach to it. Anyway, let's start the proof. We start by drawing our rectangle and putting all the vertices. Now, from A, we send out a line that goes into vertex that we're going to call E. Now from E, we send out this other line that goes to this vertex that we're going to call F. And we do so that in E is a right angle. And now from F, we send it back to A, so that we have a right triangle. And the hypotenuse of this right triangle we're going to determine as 1. This angle here, between A, B, and E, we're going to call alpha. While this one is going to be beta. Now, A to E, well, it is the hypotenuse times what? The cosine of beta. Therefore, this will be the cosine of beta. And this will be the sine of beta. Now, on this other triangle of ABE, we notice that this angle here is 90 minus alpha, because it's a right, this is a right triangle too. Therefore, 90 degree. This angle, what will it be? Well, this whole angle here is 180 degrees. Minus 90 degrees of this right angle here, minus 90 minus alpha, gives us alpha. This is a right triangle there. So, what is the measurement of C to E? Well, it's the sine of beta times the cosine of alpha. And over here is the sine of beta times the sine of alpha. Down here, we go back to our original triangle. A to B, what will it be? Well, it's the cosine of beta times the cosine of alpha. And E to B will be the cosine of beta times the sine of alpha. There you go. Now, from F, we bring down, let me use another color, let's use blue. From F, we bring down a new line, which forms a 90-degree angle with A to B. So we have this big triangle here, with hypotenuse always of 1, and now angle A plus B. Alpha plus beta, excuse me. Now, we can find the cosine and the sine of this angle, which is alpha plus beta, which are exactly the same angles that we were taking in consideration. So what is the cosine of alpha plus beta going to be? Well, the cosine is this part here. Therefore, it's going to be AB minus FC. AB is cosine of beta times cosine of alpha. Cosine of alpha minus sine of beta times sine of alpha. Sine of alpha plus beta, instead, it's equal to what? Well, it's this big thing over here, this big blue side of our triangle. And it is what? Sine of beta times cosine of alpha, CE, plus cosine of beta times sine of alpha, which is our EB. Therefore, this will be sine of beta cosine of alpha plus cosine of beta times sine of alpha. And here we've demonstrated the proof with this very easy demonstration, this very easy graphical demonstration, which is so easy that you can literally just doodle it on your test. Now, what about the tangent of alpha plus beta? Well, let's go back to our triangle and rectangle, and instead of putting the hypotenuse as 1, we put AB as 1. Now, considering the triangle AEB, the opposite side over the adjacent has to be the tangent. Therefore, since the adjacent is 1, the opposite has to be tangent of alpha. Now, since the tangent of alpha, EB, is equal to the hypotenuse times the sine of alpha, the tangent of alpha divided by the sine of alpha will give us the hypotenuse, which is the second of alpha. The second of alpha, let's remember,
is equal to 1 over cosine of alpha.
Now, this side here, considering this triangle instead, the sine FEF, what will it be? The opposite, again, the opposite over the adjacent, has to be equal to what? The tangent of beta. Therefore, we have to find EF a way that this one over this one is equal to tangent of beta. Therefore, this has to be tangent of beta times the second of alpha. In fact, if we do
Tangent of beta times second of alpha over second of alpha, these two simplify, and we get the tangent of beta.
Now we found EF, we can find CE. Now, C, what is it equal? It's equal to the hypotenuse, tangent of beta times,
tangent of beta,
times the second of alpha, times what? The cosine of alpha, because we're finding the adjacent side. Therefore, this will be tangent of beta. Why? Because if we do tangent of beta times the second, which is 1 over cosine of alpha times the cosine of alpha.
This gets simplified, we get the tangent of beta.
Now, what is FC? FC will be the tangent of beta, the hypotenuse, times the sine. Now, if we do tangent, the sine of alpha always, tangent of beta times 1 over cosine of alpha, which this, let's remember, it's the second of alpha, times the sine of alpha, what do we get? We get tangent of alpha, tangent of beta, times tangent of alpha. So this here will be tangent of beta times the tangent of alpha. Now, from F, we bring down again our line. So like that, we create this right triangle of AF and this point here that we'll call H randomly. And to find the tangent, well, the tangent is going to be this side over here. This side over here over this side over here. Therefore, what is this side? This is tangent of beta. So let's rewrite tangent of alpha plus beta equals tangent of beta plus tangent of alpha over what? 1, AB, the whole thing, minus tangent of this part here, FC, tangent of alpha times tangent of beta.
Tangent of beta times tangent of alpha.
And there you have it. We have found the tangent of alpha plus the tangent of beta. Hope you enjoyed this lesson of trigonometry. See you next time.